Alright, so today we're going to transition into the next module, module 11, which is encapsulation. That means structures for C and classes for Java. But before we get there, let's go ahead and do a review as a motivating example for why encapsulation is good. Encapsulation, just in brief, is being able to take multiple pieces of data and collect them together into one logical unit. So for example, the example that we'll do today is a bunch of data on books. And let me go ahead and show you what that data looks like. It's CSV data, right? We've got 20 records here, so we've cheated and we've made the first line here a number that tells you how many more lines there are in the file so that you don't have to go guessing, okay? But otherwise, there's a title, like Harry Potter and the Deathly Hallows, the author's first name, in this case it's just JK, and then the author's last name, the year that it was published, and then this is actual data from goodreads.com. I think it is. This is out of 5, I'm sure, right? Yeah, this is out of 5. This is so it's an aggregation of the average reader ratings, right? So 4.6 out of 5. Another one here, Chapter House Dune only got 3.89 out of 5, etc. So what I want to do is I want to process this data and produce various statistics and reports on this data. For example, what's the best book among this small subset of data? What's the worst book with respect to user, ratings? What are all the books written by Frank Herbert in this small data set here? Okay. So first of all, I'm going to need to do some file I/O, right? I'm going to need to process this, open up this file, read it line by line, just like you did in your lab yesterday. And I need to break it up. I need to tokenize it because I want to get the title alone. I want to get the author's first name, their last name, the release year, and this is the number that I'm most interested for these two reports. But you can imagine other reports, right? You can imagine what's the oldest book, what's the newest book, how many books were written by a particular author, et cetera, et cetera. You could come up with 50 different reports that you would want to run on this data that really only has 1, 2, 3, 4, 5, 6 tokens, right? So you could do a lot with just 6 tokens and a small subset of data here. So let's go ahead and get started as a review of what we've done over the last couple of weeks. File I/O and string processing, right? So my first goal here is, of course, to open the file, right? Read it line by line, right? And tokenize each line to get each token of data, right? And then, along the way, keep track of, let's just go ahead and do the first one first here. We'll be worried about what's the best book, the one with the highest rating. So let's keep track of the highest rated book, ... okay? So let's go ahead and open up the file. It is in the same working directory here, books.csv. To do that, it's just simply going to be file f is equal to fopen. I'm going to open it up in the current working directory. You can omit that in general, but books.csv, right? There's the file right there, okay? And I will be opening it up for the purposes of file input, which means reading the file, okay? You can do some basic error checking here. In fact, it would be required, say, in a hack or an exam or something like that to make sure that that's there. But I'm going to go ahead and skip over that part. Let's go ahead and read it line by line. Well, if I want to read an entire line, then the tool that I want to use is forgets, right? Forgets returns a pointer, right? Char star line, right? Equals forgets. Why? Because if it reads line after line after line after line, when it gets down to the end of the file, what happens? It returns null, okay? Actually, let me undo that. There we go, right? So, forgets. I'm going to read into a buffer at most 1,000 characters from the file f, which means, of course, I need that buffer, right? So char buffer of 1,000, right? Why 1,000? Well, every single line here is reasonably within that limit, right? You could probably kick it down to 200 or something and still be safe. But I'm just going to go ahead and bump it up to 1,000 here because that's a nice round number, right? So I've read the first line here, right? So read the first line. If I've read the first line is actually not data. Well, it's metadata telling me how many other pieces of data are in this file. So how do I convert that 20 in the first line into an integer that I can then use? Int num lines, right? Or something like that, right? Num records, actually, because there might be blank lines at the end. This first line here, of course, is a line, but it's not a record, right? So how many records are there? How do I change this line or this buffer here into an integer that I can then treat as a number? A to I of buffer. Or line, because line is pointing to the buffer right now. Okay? So there's num records. Well, if I'm told that there are 20 records in this file, right? I'm not going to be lied to, first of all. If I'm lied to and there are only 19 records, or that there are 25 records, I don't care. I'm just going to write. You told me there are 20 records. I'm going to read 20 records regardless, right? It's on you if this is bad data. So I have an argument here for, instead of using a while loop to read line after line after line after line until you get to the end of the file and forgets returns null, maybe I have an argument here for using a different loop, a for loop. For int I equals 0, I is less than num records, I plus plus, right? Why? Because now I do know how many records there are, right? Unless you're lying to me and it's bad data or something, right? So now let's go ahead and read the next line, right? Dot, dot, dot. And that's going to be, you can write it like this, line equals forgets. I'll just copy this. You don't have to capture the line anymore though, right? Because the line was being used to determine, am I at the end of the file now, right? Is it null? That was when we used a while loop instead. But now I'm using a for loop, right? You can go ahead and forget whatever this is if you want to, or you can go ahead and capture it. Right? You could capture it and do some error checking. You told me that there were 20 records in here, but there are only 19, and so line is null, error message, and quit, or something. Right? You could do that. All right, otherwise I've got that next line. This first one, Harry Potter and the Deathly Hallows by J.K. Rowling, 2007 with 4.62. That's 1, 2, 3, 4, 5 tokens. I miscounted before. 5 tokens here. Okay. So how do I tokenize each line of data? This is what I'm doing now. Tokenize each line to get the tokens of data. Right? So let's do this. The first token is going to be the title, right? The title is going to be a string. Right? How do I tokenize this line, or this buffer right here? str, toke, right? And buffer. And what is my delimiter? Well, it's CSV file, so what's my delimiter? A, comma. Okay, there we go. There's the first one. The second one is the first name, so char author first name. Right? I make another call to str_toke buffer with a comma there. Is that right? Remember, the first time that I call str_toke, I pass it the string that I want to tokenize, the line. Right? Each subsequent call, though, what happens? I pass in what? To indicate that I want to continue tokenizing the same string. Null. Right? There's the author's first name. There's the author's last name. There we go. Oops. Last name. And what's next? The year. Right? So the year is not a string, right? We shouldn't treat it like a string. We should treat it like an integer, right? Year released, right, is equal to. Could I do this? str_toke. Well, I mean, I could, but that's going to be a memory address, right? Is it going to be 2007? No. Memory address is the address. It's not the contents of memory. So once I've gotten this, maybe I'll do like a year string, or is equal to this thing. Once I've got that, then I can convert it just like I converted the first line, a to I of year string. You could probably have done that in one line as a one-liner instead, right? Call str_toke to get the next token and pass that immediately to a to I. Right? I'll do it in 2 lines. And then finally, well, the last one, value here is 4.62. So that's going to be a double, right? Except that I'll use the same trick here, right? Rating as a string, is going to be another call to strtoke, and then I'll have the rating is equal to a to I of rating string. A to I, A to F for floating point numbers. Right? Let's make sure that this actually worked by printing out all this information. Right? So printf title is equal to %s and the line, the title. Right? Print all the rest of it. Right? I'm just reading it from a file just to print it by, I'll go ahead and tab in here or something like that, by last name, comma, first name. Right? So author, last name, comma, author, first name. There we go. And printf tab over released in %d with a released, here I'll go ahead and just go colon, I'll keep it simple, %d and the line, and that was the year released. And then finally, the rating. Oops, tab over rating, and it's not D, it's going to be F, there we go. And I don't know, surround it with some nice ASCII text art, right? There we go. Get rid of that title. Oops. And put one at the bottom too. Right, so that we'll have a bunch of records and we'll have a nice delimiter between all those records. Let's go ahead and try it, except for, what should I do? Along the way, keep track of the highest rated book. I want to do some ad hoc testing though. I want to make sure that this works before I continue. I need to make sure that I close my file. Did I call it F? Yeah. In order to make sure that I'm not corrupting the file. Okay? GCC demo. A.out. There we go. So, all the way at the top here, there's Harry Potter, The Deathly Hallows by Rowling, JK, released 2007. 4.62, blah, blah, blah. What's the last book? A Game of Thrones by George R.R. Martin, right? Or A.R. Martin, what is his middle name? Oh, nobody cares. All right. Released in 1996, 4.45. Right? I don't blame you. All right. You know, people give him crap for not writing the last book, but I've got another, Patrick Rothfuss. Anybody read him? Oh, okay. Well, he's been that third book in that series is like 20 years late. Anyway, there, books. Yay. We got all that data. Along the way, let's keep track of the highest rated book. Okay? So before we print it out, let's do that. Right? So let's go ahead and compare the rating. If the rating is greater than the highest so far, right, rating that we've found so far, then I'll update the rating to be the highest rating to be equal to the rating. Right? Okay? Now, of course, I will need this variable. So before I even get started up here with the number of records, I'll go ahead and initialize that variable. What is a sensible value to set it equal to? I want to find the highest rated book. Should I go ahead and put this up to 10? Right? No, because I already know that the book ratings are on the scale of 0 to 5. Right? So there will be no book that is greater than 10. So what's a better way of initializing that variable? No? -1 is reasonable. 0 is reasonable, right? Because any book that has a rating is going to be greater than 0, right? -1 is probably safer, right? Okay? -1.0, okay? Then at the end, let's go ahead and report the highest rated book. Printf. The highest rated book was, I don't know, with a rating of %f and the line. And that's the highest rating. There we go. Let's find out what the highest, oops, I misspelled it. Highest rating. Highest. I spelled it correctly everywhere else though. All right, good. All right, let's run this. So what was the highest rated book? I don't know, but it had a rating of 4.62, right? So how do we keep track of that information? Suggestions? Yeah.
When you set the highest rating, you could keep track of the
Highest rating. Oh, you could keep track of the first and last name. But what if it ended up being Patrick Rothfuss with multiple books, though, right? We don't know who that is. So let's go ahead and go with the highest rated title. All right? And what kind of variable is that going to be? Well, a title is a number. No, it's a string. I'll just go ahead and make it large, 100 here. So that every time we find a new highest rated book, right, highest rated title, we set that equal to the title. Is that correct? Nope. So some of you may, along the way, may have been getting like, I don't know, Padres all the time in your lab the other day. Why? Because you might have been using an assignment operator. Do assignment operators work for strings? Nope. How do I get the contents of one string into the contents of another string? str, cpy. Right? And that's why the ordering is like that. It takes the one on the right and puts it into the one on the left, just like an assignment operator, but you cannot use an assignment operator. So now instead of question mark, you can go ahead and print this out as well. Okay, so now what was the highest rated book? Okay, it's Harry Potter and the Deathly Hallows. Who wrote it? Now you all know who wrote it, right? Because this is a small data set. But if I had millions and millions of books from goodreads.com, right? Would you be able to, and if you were unfamiliar with the book, right? Would you be able to know? Not with this data. What would you have to do? Go back into the CSV file, find that record, find that last name, first name, and report that. Or, okay, well, let's go ahead and write a program to do it, right? Char highest rated title book author. There we go. And we'll just go ahead and put a 100 in there. Okay. So you see, okay, so when was its release date? Add another one. Add another one. Add another one. Right? Do you see the kind of crap built on top of crap that we're doing here? Right? Every time we want another piece of data, we're going to have to create another variable over here, another variable, right? There's got to be a better way, right? Let's think about what a book is, okay? A book is a title, author first name, author last name, a release year, and a rating, right? 5 things. Those 5 things represent one logical unit, right? A book. I would really like it if I could define a book, right? Book B, right? And then the book B2, right? Book B1, B2, B2, B3, whatever, or an entire array of books, right? Say 50 different books that I've got, right? It would be really nice if I had this built into the language, right? At least for this particular application. I don't. Right? I'd really like to use it like, say, an integer. Right? Just a number, you can just declare it and use it. Right? It's built into the language. I would really like to use a floating point number. Right? Why? It's built into the language. I'd really like to use a book type, but it's not built into the language. That's what encapsulation is. Right? Encapsulation is defining your own types so that you can take multiple pieces of data and collect them together into one logical unit. Right? And we've from this exercise, we've already seen the limitations, right? So introduction. The built-in primitive types are very limiting. Not everything is just simply one number or one character or a collection of characters. Not everything is a string. Right? Some things like books are 5 things together. And in fact, this is just a small subset of data, right? What else would we want? Maybe the release month, the release year, the edition, the number of pages, right? You can, if you just start thinking about what a book is or what an album is or what a person is, etc., then you start getting all these pieces of data that are relevant to that thing, right? And that you want to model in the real world. Real world entities are composed of multiple pieces of data. And that keyword there, it's not a keyword, but that I guess later on, a vocab word, composition will be used when we're talking about, say, Java, right? Okay. Encapsulating multiple pieces of data into one object or thing allows you to deal with that one thing, right? Instead of, oh, I need to deal with the title and also the last name and the first name and all these pieces of data, I need to deal with them all separately. You saw the consequence also of that in your lab yesterday. How did we end up organizing MLB teams, right? Even there was just two pieces of data, the name of the team and their win percentage. We had to keep track of two different arrays in order to do it. Now, we wrote all the code to do it for you. That sorting those means that, oh, these two teams are out of order. I need to swap them, but I also need to swap their rating. Right? If they had 5 pieces of data, then I have 5 arrays. And if these two teams are out, these two books are out of order, I need to swap it in this array, swap it in that 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 array. Right? Whereas if I had kept everything as one logical unit, this book and this book are out of order because their ratings are different. I need to just swap those two things instead of 5 different things in 5 different arrays. Right? And that's what encapsulation is. Right? In C, that means structures, and in Java, that means classes. Okay? Formally, what is encapsulation? Encapsulation is a mechanism that allows you to do 3 things. One, group pieces of data together into one logical unit. Right? 2, protect that data from the outside world. Right? And 3, group functionality that acts on that data with the data. Right? Now, C is an older language, right, from the 70s, before what we would consider modern object-oriented programming. And so it only supports one, right, the grouping of pieces together into one logical unit. Object-oriented programming came along and added the other 2 conditions, where you're protecting that data from the outside world, and where you're grouping the functionality that acts on that data or operates on that data within the same logical unit. So for example, Java classes, you have these keywords called private, public, and protected. That's the way that you can protect the data, number 2 here. In Java, you have classes, and you can put methods into those classes, functions into those classes. And so it supports all 3 of these things. We'll start out with C here, where we only are able to support the first one, the grouping of data into one logical unit. Before we do that, let's consider other things. What's the worst rated title? So copy, paste all 3 of these things, and guess what? Lowest. 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 Right? Do we even want to complete this? I'm not really jazzed about doing something like that, because that's just the first two reports here. What about all the books written by Frank Herbert? Right? Now you're talking about how many books were written by Frank Herbert? Let's just say 5, right? Now you're talking about 5 more variables times 5, 25 variables to keep track of all that information, right? This is a nightmare, right? Let's not go down that road any further, okay? By the way, do we want a review in Java of how to do this? Yeah? Okay. So let's go ahead and take the code that I'm going to go ahead and get rid of this, right? I think that the lowest book is probably Dianetics by L. Ron Hubbard. Is that right? Yeah, looks like it. All right? I just put that one in there as a joke. All right, so let's go ahead and take this code over here to Java, and let's translate it, okay? First of all, how do I open up a file in Java? What? A scanner, right? Scanner s is equal to new scanner, and we'll put in a new file, and that file is going to be Actually I put it over here in the data folder, books.csv, so it'll be in data/books.csv. There we go. Oops. There we go. Do I need a buffer? No memory management in Java, right? If you want a string, go ahead and give yourself a string, right? So I just need to read the first line. Int, and how do I, num records, how do I convert it immediately? Integer.parseInt s.next. Actually, I don't even need to do that, do I? I'm going to need to do it. Let me go ahead and get the first line. So string first line is equal to s.next line, right? And then integer.parseInt of first line. That will give me n, right? The number of records. Highest rated, okay, I'll go ahead and go like this. This is a character array, but that means a string in Java, right? There we go. And I don't specify the size because that's taken care of for me. There. Translate, translate, translate. Right? Okay. Just in case you're wondering, there are things called transpilers. Right? It's not a compiler, it's a transpiler. What it does is it takes one language and translates it, transpiles it into another language. So you might be asking yourself, why do we have so many languages? I could just write in one language and then write transpilers to translate my C code over to Java, vice versa, et cetera, right? Yeah, it all works until it don't, right? There are plenty of attempts at that kind of stuff so that you can have one universal language that transpiles into every language. There are always problems, right? It never really works in real life, okay? So let's read the next line. To do that, it'll be string line will equal to s.next line. Okay. Tokenize the line. How do I do that? I don't use strtoke. In Java, what do? I chop up the string and I split it, line.split, according to commas. That returns a string array, tokens, is equal to this. Right? Now I know that the title, string, is going to be the first token, tokens sub 0. I know that the author first name is going to be the next one, et cetera, et cetera, et cetera. Let's go ahead and do it like this, so I don't have to type. There we go. And this will be tokens sub 1. Token sub 2, token sub 3, token sub 4 is going to be an integer, so that's going to be integer.parseInt of the year string. This is going to be a string, which is tokens sub 4, right? And this isn't going to be integer.parseInt, it's going to be double.parse double of the rating year string, right? Almost a line for line translation or transpilation, right? All I'm going to do here is keep track of the highest rated title being the title. And now I am in Java and I can use the assignment operator on strings. Right? Okay. Change all of this to system.out.printf. No other changes needed. System.out.printf. How do I close the scanner? Dot close. Right. Highest rated title, highest rating. Why are you complaining about that? Highest rated title. It might not have been initialized, so let's go ahead and go with null. Right, there we go, and null. There. Now it's happy about that. It's not happy about that though. What's the problem? If I hover over this, what is it going to complain about? That it throws a file not found exception. It's one of those nasty checked exceptions that I am forced to surround with a try catch statement. and then release. All right, I'm just going to go ahead and do it on the entire thing. Try all of this stuff, catch any exception. I don't care if it's a file IO exception or whatever, and just simply rethrow it. Throw new runtime exception of E. There we go. Now it's perfectly fine. Saved, run it again. Exact same behavior as before. Harry Potter all the way down to Game of Thrones, and the highest rated book was still Harry Potter and the Deathly Hallows with a rating of 4.62. I don't know, maybe your generation would not have grown up with Harry Potter books, would they have? Okay, we would? Okay. So maybe you agree with this, maybe you don't. That was just some subset that I grabbed off of Goodreads. Sorry, I don't. I was too old for it. All right. Let's see. Redwall? Never read the Redwall series as a kid? All right, fine. Go back and read them. All right, so encapsulation. So let's go ahead and, again, C supports structures, the number one. Sometimes, in fact, I don't know if it's just me or if other people use that term, it's weak encapsulation, right? It's not strong encapsulation like Java has, where you're supporting all three of these things. So let's now in C, let's start out in C and write what's called a structure, right? So C, structures. Right? A structure is a user-defined type that allows you to create a new type of variable that consists of a grouping of other variables. Right? So let's just jump right into it over here. What I'm going to do is I'm going to create another file here. I'll call it book.h. Oops, I want it over here in 156. Yes, there we go. All right. I'm going to call it book.h because it's going to hold book stuff. Okay. We've seen this this before. We've seen some of this syntax before. Type def. Do you remember where we saw that in C? Type def enum, right? An enumerated type. We're not going to define an enumerated type though. What we're going to define is a structure. And the key word for that is struct, right? You're only saving 3 letters, but in 1970s, if you could save 3 letters, you did it. Right? We need to provide a name for this structure. Well, if it's going to represent a book, what should I call it? Book, right? There you go. Ends with a semicolon. Now, another thing that people do is books, pluralize it. What's a potential problem with that? Well, first of all, is it actually books? It's one book, right? Do you pluralize things that are one thing? No. Also, what if you have something else like a person? Right? What's the plural of a person? People, right? That's acceptable. What's another one that's acceptable? Persons, right? So in English, is there a nice rule for pluralization? 90% of the time you just add S, right? Sometimes you add, though, ES. Sometimes you change the Y to I and add ES. Sometimes it's a completely different word, like people and persons, right? Axis, axes, right? I'm sure that you can think of other irregular pluralizations like that. But in any case, don't go down that path. It represents one book, okay? So don't pluralize, okay? Note here, what else did I do? What kind of casing did I use? I used upper camel casing for this. That's the modern convention, okay? If you've got multiple words, each letter, the first letter of each word is uppercase, the rest of it is all lowercase. There's book. It's only one word though, okay? Logically, what is a book? At least according to what we're saying a book is. It's a title, char, title, right? What else is a book? Char, author first name, Right? Char, author, last name. Right? What else? A release year. And finally, a rating, a goodreads.com rating. Okay. Note the syntax there. Everything that I just declared you are well familiar with, but unlike a tight def enum where it's an enumeration, a list, the first thing, comma, the second thing, comma, the third thing, comma. This is not a list. This is a declaration of what a book is or what belongs to a book. A title, a first name, a last name, etc. Right? So what do we end each line with? A semicolon, not a comma. Right? It's not a list. The order generally does not matter unless you want to get into the really nitty-gritty stuff of how this gets padded out in memory and stuff like that. Don't worry about it. Okay. I am thinking though now, what about that first name, last name there? Let's touch book.c, right? And try to compile. Let's go ahead and open up book.c and include, include the book.h header file here so that I can actually compile it and ask, is my syntax correct? Book.c, compile it. Okay, my syntax is correct over here in the header file, okay? It knows about a book now. But what about that author first name, author last name? What if I wanted to support more data? Like J.K. Rowling's birth date, right? Or something like that. What would I end up doing? Add another author date of birth, DOB, right? Except that, does that really have any bearing on this book? It doesn't seem like the author's date of birth has any relationship to the book. The author themselves, they have a relationship to the book, but it doesn't seem like this stuff should be in here, right? So an author first name and last name, if I've got at least two pieces of data that define one logical thing, what should that be screaming out to you? If I've got 5 pieces of data that define one logical thing called a book, I created a structure for it. If I've got 2 pieces of data, and maybe a third, date of birth, that represents a person, what should that be screaming out to you? No? Create another structure called author, right? Move this author stuff into the author structure. And then over here in the book, you can have an author. That's kind of cool, right? Now I'm logically organizing data where it belongs. Author stuff belongs in the author structure. Book stuff belongs in the book structure, right? Et cetera, et cetera. Now, is this going to work? Let me go ahead and try to compile this. What author? What the hell's an author? That's what it's saying. So if you're, if I'm a dumb compiler, I'm just going along here. Okay, a structure called a book, great. I know what a character char star is because that's built into my language here. I know what an integer is because it's built into my language. I know what a double is because it's built into my language. Wait a second, author, what the hell is that? Right? Where is it defined? Down here. So in other words, order matters. Right? It needs to know about the author before you can use it. Now it'll compile. Right? Okay. Well, if I want to support the author's date of birth, what else is that? Date of birth. I don't know when it was. Let's go Patrick Roth. He's still alive. Date. Yeah, see, what's the top Google hit? The third book in that series that still has not come out, right? So date of birth. In fact, I think he raised $1 million for charity, promising that if he raised the money, he would release a chapter. And they raised the money for charity, and he never released it or something, right? So you could look that up. But what's his birth date here? Maybe Wikipedia would be the most reliable. There we go. There, June 6th, 1973. Okay. So, how do I write that? June 1st, 1973. If I wrote it like that, what kind of data is that? That's a string, right? So I could represent their date of birth as a string, date of birth. That's one option. Is there a better option? Because if I represented this like a string, what I just wrote, right? June 1st, 1973, versus what if I wrote it like this? 1973, like a good computer scientist, and wrote it as a lexicographically orderable string with padded out zeros. Right? I'm glad that it was some of them began with zeros. That's the proper way of writing dates as strings in computer science. Why? Because this is lexicographically orderable. Right? This is not. Right? August would come before June if you ordered it by using lexicographic ordering. Right? So, no. At the very least, you would use ISO 8601 format. That's another way of representing a date. Right? What does it look like? Well, here's what year, month, and date look like. Come on, popular standards. There we go. Nope, that's not it either. This is the ISO organization. Terrible, you don't even give me a full example. ISO 8601 Wikipedia. Wikipedia is going to give me one. There we go. There. That's the proper way of writing out full dates and times. The date in lexicographic order, separated by a T to give me 24-hour time with a Greenwich mean offset. Perfect, right? That is completely unambiguous, right? But it's still a string. So what's another option? If I just want the date, I'm not worried about the time. I don't care when he was born or what time he was born. Right? No? Yeah.
3 variables.
Okay. There's the year, right? There's the month, and there's the day, right? Except, wait a second. I've got 3 pieces of data that logically define one thing, a date. What should I be doing? What is this screaming at me to do? Make another structure. Type def struct date. There we go. And put those in there. Right? And now I can put this in as a date, which is going to be my date of birth. There we go. This is what composition is all about. Look at a book. That book is composed of 4 things, right? The title, the author, the release year, and the rating. The author is composed of 3 things: first name, last name, and date of birth. The date of birth is composed of 3 things. So we've got this thing is composed of that thing is composed of that thing is composed of that thing. Right? The order here does matter because if I put the date down below here, then it wouldn't know about it over here in the author structure. Right? But in so doing, you've now created a string of data relationships, right? And you can reuse these things. What if I've got another, I don't know, release date, right? Release date of the book itself, right? We've got a release year here. We could go ahead and change that into a date, right? And now these 2 pieces of data can use the same piece of data that I just, not the same, exact same piece of data, but the same designed data, right? I could reuse this date for a date of birth and a release date instead of just a year. Right? If I rename this author and I rename it as a person, now that person can be an author sometimes. They could be an editor. They could be a student, right? I'm logically creating a person that has multiple uses in my data modeling, right? By separating these out and creating these logical units, I am reusing data. I do not have to have 50 different arrays or anything to hold all the different pieces of data. I now have logical units that organize this data. Okay. All right, let's keep it simple though. Let's go ahead and go with just a release year, because that's what the data is. All right. Now that I've designed this, let's come back over here to the demo and rethink it, okay? In the next 5 minutes, yeah, here we go. So I've got all of these pieces of data now. Right? I want to create a book from the above data, ... All right? So book B, right? How do I, just declaring it, right? I've got a book now. That's not a siren, right? I've got a, is it? Yes, it is. It's the first Wednesday. So, all right. Well, if it gets too loud, that's all right. We can go ahead and quit here. But otherwise, how do I create this now? The point that I was going to try to get across to you over the next 5 minutes here was that, well, now I've got to go B dot, what is it? Title is equal to a call to malloc, char malloc, of a certain size, right? I've got to do that for the title. I've got to do that for the author. I've got to do that all over and over and over again. And so I'm going to have at least 10 lines of code here. When you've got 10 lines of code, put it into a function. That's what we'll do on Friday.
May I have your attention, please?
All right.
May I have your attention?
A reminder,
A tornado
we have pizza at 11 o'clock, so in about 40 minutes up on the third floor as our student advisory panel. Right? Come and ask questions. You don't have to ask questions if you don't want to. You can take the pizza and leave. Right? There will be plenty of leftover pizza. Trust me. We never go through it.